Um, so in addition to KDB use case and Redis database, the other use case we are finding a lot of success in US, in China, is this BioScience use case. I know we may have talked about that a little bit earlier, but let me just kind of refresh that and give you some of the latest data we are seeing with our customers. So as you know, genome sequencing, with the advent of COVID-19, genome sequencing and all the things become very, very popular. And we're getting a lot more demand from customers in US and other countries who is interested in this type of use case. So what is genome sequencing use case, and what does it look like, right? With genome sequencing, typically you have a workload. We call that a pipeline. A pipeline typically consists of many, many steps. So over here in this example, it has 11 steps from step 1 all the way to step 11. It requires a lot of memory to run this workload, and it uses a lot of network switching, backend storage to hold all that data. For every step of the pipeline, it needs to run the entire process, computation, finish that, save the data from memory to storage. And when that finish, it needs to reload the data from storage to memory to continue on the next step. In some cases, when you're in the middle of a pipeline, you may have to go back to a previous step, depending on some of the parameter that you have tweaked during your sequencing process, right? And when you do that, you have to obviously, flush all the memory cache, reload all the data from storage again to a previous step, and then rerun it again from there. And this is what this arrow is all about, right? Is to go back to a previous step. That is a very common operation they do in this biotech pipeline. So what we're presenting here is a much simpler and a much faster way to run these pipelines. Instead of saving and then reloading from and to storage, we are going to leverage the Optane PMEM in two ways. Number one is we are going to use PMEM to hold all that data in a memory tier, right? We can hold multiple terabytes of the data in a memory tier without having to go all the way to storage every single time. And that obviously increased the performance, reduced the time. Number one. Number two is we use snapshots. We use memory snapshots, right? We basically doing snap, 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 snap versus saving and then reloading, saving and then reloading. And this is a dramatic improvement of this pipeline. The second thing is our snapshot can also make this sequential waterfall type of workload more parallelized, right? We can turn a single thread application into a multi-threaded process by leveraging our snapshot. So over here, we take a snapshot on the stage 1 or 2. On stage 3, we can expand that into 3 stages by using our clone at the same time. And this allows you to shortcut some of the steps. And then you will see an actual example at the end, how we did that. Okay, so this is another way to increase the usage of the resource, the memory, the CPU on the server, and then reduce the time of the overall processing. Mm-hmm. As a result of all this, the overall process time can increase by a factor of, if you look at here, right, this number here, this is improve the execution time by 25x for stage 5. The reload time from storage can reduce from 800 seconds to 1 second. So it's a just huge improvement overall.
Hey, Charlie, on the 2 slides before, where one more back there. So in those clones, Yeah, on those clones, what's happening with memory? Do you have to have like triple the memory, or how does that work?
Yeah, so with a clone, we call that thin clone. Basically, when you clone these stages, stage 3, 3B and 3C, they are not going to triple the memory usage. It's only going to increase a little bit, right? And because the cloning is really pointing to the same memory pages.
So you only froze that stage.
Yes.
So the stage where you just froze it, and from that stage, then you can continue doing all the other workloads, different workloads in parallel.
Yeah.
Right?
Yes.
I understand that. Yeah.
Yeah, and then it doesn't use 3 times the memory. You are still using the same amount of memory as before. Mm-hmm. So you don't have to use 3 times more memory. Mm-hmm. That's the benefit of the thin clone.
Mm-hmm. Yeah, I understand that. Yeah.
So yeah, overall, you can see here the completion time is hugely improved. The blue bar is the net, the CPU computation time it took for this job. And you can see here, there is no difference, right? We're not going to be able to save your CPU clock time, but we're going to save dramatically on the IO time. So the IO time reduced from 61% here to only 3% with our big memory. Okay. So this is an actual POC we are running right now in US. And this is, on the left here is the existing running job of this pipeline. It takes 6 hours and 31 minutes. This is a 1, 2, 3. It's like a 3-stage, not 11 stage, right? It's a shorter pipeline, 3 stages.
Right.
And stage 1, 1 hour 39 minutes, 1 hour 39 minutes, no change, right? Same. With stage 2, we reduced from 2 hour 48 minutes to 1 hour 16 minutes, right? How did we do that? Well, we first took a snapshot and then we create multiple clones. And we let these 4 steps run in parallel, right? On the original job, you have red, yellow, green, blue, like they all mix together. But over here, we separate them and then we let them run in parallel. And that really reduced the overall time for stage 2. So we saved about 1.5 hours on this.
Okay.
And Charlie, that's mostly due to the lack of threading in the processing stage, in that stage?
Yeah, that's due to being able to turn that single-threaded application into sort of a multi-thread using more CPU core. Yeah. Right. To parallelize it, yeah, and then use our memory snapshot and cloning. Right, and then the next step, stage 3. This portion is also about the same, 1 hour 15 minutes. But the final step in stage 3, save the data to files, took 48 minutes. With us, less than 1 minute.
Okay.
Right? We just boom, take a snapshot, boom, done.
Yeah.
So this is what we did, and then we show that to the customer. They're very interested, and they give us this data set as an example, and then we can try on even bigger data sets, and this would be a huge win for BioScience workloads.